But now we go back to wind erosion. Thomas will present a project dealing with wind erosion.
Yes, thank you. It's me again. And again, I have to force you into something not as biological or social. I'm sorry, it's physics again, wind erosion. But we deal with hedgerows. And the results or the contents I present you now in short words are coming from the last 3 years of a research project which we conducted here in Lower Austria, in the east of Vienna, Machfeld mainly, together with the University of Nitra in Slovakia and in University of Kent in Belgium, and the Research Center for Forests in Austria in Vienna, and we are still Federal Agency of Water Management. Therefore, wind erosion, most of the farmers or people who are moving around our landscape are quite familiar that wind erosion is happening, it is a phenomenon, but the quantity and the relevance is still widely unknown, and therefore we wanted to generate some numbers. Again, as I said before, we cannot help, we need numbers somehow. But before the numbers, some pictures here from the late winter this year. There was a huge wind erosion event in, where has it been? North from here, in around Hollabrunn, in the wine quarter of Lower Austria. And here you see, this is not clouds or something. This is our fertile soil flying around in the air, causing lung cancers and whatever, or traffic accidents. Again, the same event. And this is how it looks on the soil. A little bit, I guess I have, yes, zoomed inside. So it's not like what we know as soil. This is entmischt, so the grain sizes are changed quite a lot. There are some grain sizes which are moving a lot, some grain sizes which stay here. So this is the grain sizes which were rolling on the floor and then accumulating at the border of a field. So this is a field border. Here you can see the grass. Here is also the wind speed is slowing down, and therefore some parts of the soil are deposited. And also here we see it as in a bigger scale. Deposition here and erosion here. This is a picture from the project partners from Slovakia, so it's quite next to the border of the March, the river March, and there somewhere the area are very sandy soils which are quite heavily moved by wind. And what is here? The hedgerow. You see, hedgerow causes a soil accumulation of nearly 1.5 meters or something like this. What did we do? We developed some strategies to come to our numbers. The first one was to measure wind erosion in these little sediment traps here, which were installed in 2 fields in the Mark field in a semi-randomized sampling design. And every 3 weeks we emptied these little plastic boxes and took the mass of the sediment or the transported soil. And these are the analysis of this data is not as easy, or it's quite complex. I'm still not sure if I did it the right way. Why? Because it's a 3-dimensional motion, right? The air is not as, or if you compare it with water erosion, this is 1.5 dimensional, let's say. So water is coming down from the air, and then it runs downwards. No, there is only one direction where the movement is. Wind erosion is different. It can move anywhere in any direction, and therefore we have to develop some algorithms for that. And so what we can see here as a first rough estimation results is that we took one covered soil, one bare soil throughout 4 different periods. So vegetation period is always covered by plants. Winter period is nothing is growing there. And the interesting thing is the amplitude, so the range between something like 100 kilo per hectare up to 10,000 kilo per hectare, which was also coming, or was more or less accidental, maybe because this was a maize period, and exactly at the time when there was very much bare soil, so at the seeding period, also the heavy wind events were coming. So this is a huge number even for water erosion, and I wouldn't dare to say this is something like an average or a typical value, but we can later on. For comparison, we also did a modeling study in this area. So here is Vienna, and this is the eastern part of Vienna, highly productive agricultural land. And we used two different models or two different methods to model the wind erosion risk over there. The one is this DIN, German norm, whatever. This gives us only classes, high, low, very high risk. So it still looks quite green. So our soils are not the most susceptible for wind erosion. And here, the second one gives us the RWEQ. Where is it written? Nowhere. It's a standard method which gives us quantitative information about wind erosion risk. So it's not actually not measured, and we also have no measurements to validate the method. But still, we see some small yellow and orange parts here. If you're a little bit familiar with the geography, this is this sand belt near Gensendorf. And there we have, yes, this 10 tons potential. So it sees our measurements are quite going in the same direction. A second thing we developed besides this modeling study was a GIS tool to find the best locations for the new installation of new windbreaks. Yes, as I said, it's a GIS procedure algorithm of 8-9 steps, I guess, and then here you can see if we would plant windbreaks here, this would have the most effect on the overall wind erosion rates or accumulated masses. And third thing I want to shortly present you now was an inventory of 50 windbreaks in exactly the region we saw before, where we had a look on the vitality of the windbreaks and also compare a little bit. So we did this together with an ecologist, vegetation ecologist, and we wanted to see a little bit which species are in good condition and which species are under threat, let's say like this. What you can see here, very small letters, ligustrum, rosa canina, crategus. So this is the abundance of the different species. And we also found in this study that most of the windbreaks have quite a low diversity of species. But more interesting is this result here. Here you can see the different species and the vitality classes. So here, for example, let's see, and it's also split in 3 different soil classes of soil water. Yeah, how much water the plants can get from the soil water conditions. That's the English thing. And here, Acer pseudoplatanus is a very common or very abundant species in this region. And you see, especially on the dry soils, it's nearly completely dead already. But it was planted throughout long decades. And yes, obviously it has no future in this area, this tree. And there are many more species, and I don't want to go into detail as evening is coming. Therefore, I thank you again for your attention, and I hope you are as passionate about wind erosion as we are now. Thank you.
Thank you very much.